If you want to draw in perspective with perfect accuracy from flat silhouettes into 3D views, watch this one point at a time process. In part 1, I explain the why of it all, so watch that first. Here I'll talk about how. If you struggle with how to draw accurately in perspective, practicing this skill will help you understand how it happens. Here we go. Let's do a more complex object. You can draw with me, stopping and starting the video as we try something more complex than a box. I planned it out in front, top, side, and even 3/4 views, but in rough drawings that are not precise. We will now draw a precise version of it. And we're going to do something a little different here. We're going to give this a couple extra attributes. We'll make a square in a square by using a diagonal, a trick to keep proportions consistent. In a later lesson, I'll champion diagonals as the great fast solution for perspective problems. This is the great slow solution, projecting a plan. We're taking that and moving it like that. Well, it makes sense that perfectly vertical lines would come down like that to give us a top view. And we see it's up to us now how high this thing is. But I'm going to say that this portion is going to be a bit of a tower. Let's make it so that it is about this tall or this tall. Okay, so it projects up out of there. And this part that's down into there is going to be the slope. Like that. And incidentally, I should have done this all the way across. That slope goes all the way across. I'll even pretend like I'm doing it in perspective. Slope. Now it makes sense that looking at the oblique, this tall part sticks out in that slope, which we can't tell is a slope from this point of view. And then this part here is going to be back into there. How do we know that? Well, we need another view, don't we? We're going to take this one and we will slide it this way. So that means all these height measurements, which are horizontal lines, can transfer over as they would. And now we need to transfer the distance from here and there. We need to transfer those over so that they go like that. That was a measurement on Z. This is a measurement on X. And these are measurements on Y. So now that Z goes this way, let's translate the heights, which shouldn't be too difficult. We know that that back plane, remember that's this plane, the one that is back on Z here, going this way. We changed it to another position. And what I have just done is made this line go back this way. And then when it comes to here, what we can't tell is that it slopes down. But if we know that it will, we determine it slopes down, so let's slope it like that. And now what else have we got? Well, we know the whole thing hits the floor, so we're safe in doing that line. Oh, that's it. See, that's the slope looking down on it. This is the slope looking down, and here it is looking at it on the side. Let's project it now. I think that I'll slice it out of here. Now we can place this in any position we want. Let's put it at a position about like that and put our vellum over the top of it to keep things clean and run our picture plane line right along the edge of that corner, which will touch the picture plane, leaving it unforeshortened. And we can carry that all the way out there to find where our vanishing points will be if they're distant. And let's place our viewer about here. So we're pretty close to this. The center of vision will aim right there. We could put it to the left or right, and that would change our view of it, but it might distort it. We'll keep the center of vision safely near the center. Now, we run from corner to corner, enough to find the important intersections. That's that slope. And each one of these on the back corners, obviously important. That's going to intersect there. What about that other back corner? That's going to intersect there. And what about any others? Yeah, this corner will be important. And it's going to intersect right there. And this other corner will be important. Looks like that one and that one are going to just conveniently fall on the same line. Well, I suppose we could do that one, but we don't have to because we could find it on the front and project it back. But just to make the point, it's every corner that we care about. Now, we have placed our plan and placed our viewer, and we have done our intersecting lines, but we are not done. We have one other important thing to do, and that is to place the vanishing point for the lines that go away to the left and right. We want to place the vanishing point for that by taking a line away to the right. That's a VP. And then we want to do the same over here. We want to send this one from this viewer and run that away to the left until we find that distant and valuable vanishing point. That is the same as this line system. Okay, that step is essential. Skip that step and you won't know where your vanishing points are. Now we can take away that thing underneath there and we are left with this. We will then use the elevations in the next stage. Well, we hardly need this anymore, so we could erase it. Or I could just put a piece of paper over it. I had that piece of paper prepared. Now, what do we need to do? We need to project down very lightly all of these corners that are so important to us. This is going to be the basic plan on which this all lands. Okay, we're going to place our horizon line next. Remember that we are taking the edge of the picture plane like this. Watch this important move. We're going like that. All of these vertical lines, when you looked at them from above, were just little dots. But then we go down like that, and we're going to see them as they're coming down here, and we're going to place our horizon line up high this time, almost as high as where that picture plane is. And that means that the vanishing point should be right there. That's the left vanishing point. VP, and the right vanishing point. And there they are. And then if we place this front corner on the ground, it's going to probably fit right about, let's say, there. And that won't be a right angle, so it won't get too distorted. And now we can run back to that vanishing point and run back to that vanishing point. And we can, since we're doing this on the ground, go ahead and continue. Remember, that one's going to intersect right there. So we'll figure that that's going to be over there. Let's make it a straight one and not a wobbly one. And we should go from this corner back to that point. And we're going to find a couple other things when we do this. We're going to find that this corner right here, when we project down, will give us a dot on the ground right there. And this one, when we project it down, will give us a dot right there. Now, those should give us that line on the ground in perspective. So why do you do it on the ground when we know from the oblique that it's up higher? On the ground keeps it simple. A floor plan to build up from. Now, what about this one? Let's find that on the ground. Shouldn't be too hard. If we can find any of these, we can figure that one is there. And then we also found that that back corner, when it came down to there and ran down, hits right on that same point that that one does. So that means if we want to get that line, we could run through there to there, running a parallel line from there to there. And let's see what happens when we do that. It should land right about there. Let's see. Does it land right there? Yes, it does. Okay, so we've got every point on the ground plane now. The next step is to build it up with an elevation. We do that by taking a front corner from this elevation and running it across, unforeshortened, to project back. The next thing we need is to get the height of all of this. And it doesn't make any difference whether we use this one or use this one. We just care about the unforeshortened height. That's the elevation. And running it to that corner and finding the true height on this line that is not foreshortened. Let's cover this up a bit with vellum so that we can work a bit lighter and then we can see the height. So I run a line from that front corner, and if we say that that is the baseline, the next line up that we care about will be this line, and we'll run that over and see that's going to go that high on the unforeshortened portion. And then the very highest height on this corner, if it were touching this corner, we have now transferred that height, and we know that this slope will go that high, and it'll go that high back here. So we run a line off to that vanishing point, and where it intersects right there will give us this line of this slope. Just do it freehand there. And where will the other line be? When I run that slope over to the vanishing point, where will the other one be? Well, we could figure, if this is the other point, and it's running down there, and it would run down to there, and then I lifted it up. Oh, look at that. It's going to land right there, and it gives us the other line of the slope. And we can connect that, and we've got our slope. We're safe to connect those two lines. Okay, now we've got this tower, which we know how high it is. It's going to be on this level. So let's figure if we're going to run that back to there, it's going to land somewhere on there. We're going to find that corner right here that goes straight up and down. And we've got this area right here, which goes how deep? Over here, we see it goes this deep. So if we run that down and see where it intersects, I think I've got this corner. It goes straight down, and there it is. That's that corner in perspective, and the other one's over there. So we could, by connecting these dots, find that one from there to there. And what about this height? We're going to have to run back to there and back to there. What's the easiest way to do it? Let's take this and run it down to there and say it's going to land at that point and go straight up and down. And then it will meet wherever this goes straight up and down, wherever it will meet as it goes toward that horizon line. And where would this point be? Well, it's right there. And we would go straight up and down, and wherever this would meet at that horizon line, and so on. We're getting up so close to the horizon now that it's making a very foreshortened top plane. If I had brought the horizon up a little higher, we would have avoided that, but it did work. And we now have an accurate projection of a form. So there it is. Okay, you've seen it. Now try it. If you want more examples, we'll do this cottage floor plan with height points behind the picture plane and even in front of it. Every point placed at proko.com/perspective.